All right, today class we're going to talk about writing and graphing equations in the form y equals mx plus b. Okay, so here you see I have my arrows drawn with the pink boxes for you to fill out what each variable means. Okay, now the equation of a linear relationship y equals mx plus b, where m is the rate of change and b is the value of y when x is 0. So if you were to see the point 0, 7, I would know that the 7 is my y-intercept, or where my line crosses the y-axis, okay? Because that's what it's saying here, that the b is the y value when x is 0. So wherever you see 0, that y value is going to be my y-intercept, or where it crosses the y-axis, okay? All right, writing linear relationships. Fiona manages an edible arrangement business that charges $15 per container plus $2.50 for each ounce of fruit in the arrangement. Okay, so $15 per container plus $2.50 for each ounce of fruit in the arrangement. So we're going to write an equation to describe a linear relationship. Okay, so again, we're going to figure out what my independent variable is, what my dependent variable is, or my x value and my y value. Okay, so here I'm going to put my x values here in my table and my y values here. Okay, all right, my x would be my ounces and my y would be my cost, because the cost depends on how many ounces I have. Okay, and I'm going to start at 1, 2, 3, 4, 5. Okay, now it says $15 per container plus $2.50 for each ounce. All right, so $2.50 per each ounce. If x is my ounces, is 2.5 for each ounce, okay? And you have plus a 15 per container, okay? So now I'm going to plug those values in to my table here. So I'm going to do 15 plus 2.5 times the 1. I'm going to get my answer. My answer. And what I want you to finish is, I want you to figure out what these two are here, and I want you to complete your table here. Okay? All right, representing linear relationships using multiple representations. So now we're going to use it doing a table, an equation, and a graph. Okay? So let's read our scenario here. Kyle has signed up for a cell phone plan that costs $60 per month. So I'm going to highlight that, $60 per month, plus a one-time activation fee of $40. We're going to represent this relationship using a table, an equation, and a graph. Okay, so first I need to recognize what are my independent and dependent variables. Okay, so what's my x and what's my y? What depends on the other? Okay, so I know that my cost in money depends on how many months. Okay, so on this table here, I'm going to start at 0. Okay, I'm going to start at 0 because that'll give me what my b value is, or my y-intercept. Okay, all right, so my cost is 40. It's a plus a one-time activation fee of 40. So 40 plus, and it's $60 per month. Okay. Continue here. I'm just going to add my values in. Remember, wherever I see the x, I'm going to put my x value there. Okay, continue on here. Oh, excuse me, I just messed up. See, Miss Webster makes mistakes as well. I just went ahead and got too happy. Okay, sorry about that. All right, so I know that my equation is the 60 times how many ever months plus the $40 activation fee. Okay, all right, so once I do all that, I'll get my answers here. Okay, 60 times 1 is 60 plus 40 will give me 100. 60 times 2 plus 40 would give me 160. 60 times 3 plus 40. Excuse me, I'm messing this all up. This would, yes, that's 40. 60 times, that's right, that's correct. Excuse me, I make mistakes too, guys. Okay, and then I finished that out there. Okay, so now I have my equation. I've done it from represented in a table. Okay, so now we need to represent it in a graph. Okay, so I'm going to go ahead and title my graph as cell phone cost. Remember, every graph has to have a title. Okay, so now what I want you to do is to label this axis, label this axis. Okay, in order to graph it, you need to find your order pairs. So I want you to find your order pairs from your table, and you should be able to do that. Your X and your Y value. Graph those points in this graph here, okay?